Today we have to discuss about that Beckmann rearrangement. So Beckmann rearrangement, here we are taking oxime. This is oxime in the presence of acidic medium. In the presence of acidic medium, or sometimes we are using PCl5, or sometimes we are using H2SO4, whatever that catalyst. Then here we get N-alkyl amides. So add R1, then C double bond O, NH, R. This is N-alkyl amides. N-alkyl amides. This is a Beckmann rearrangement. Here I will explain that mechanism here, then how it is involving that Beckmann rearrangement, what is that the final product, how it is formed the final product, I will explain here. So here RC, R1, then double bond NOH. First, whenever we are treated with the acids, which is involving protonation of alcohol, these are the lone pair donated towards C, H plus ion. Then here C R1 double bond N OH H. This is the protonation, but it is a unstable loss of water. Then here it formed R C R dash double bond N plus, but it is unstable. So here involving rearrangement, this alkyl group shifted to nitrogen. So here that again R dash C double bond N R, this one is positive charge. Again we treated with the water, then H2O. Here where is the source of water? From second step, loss of water. These are the water molecule attached to the carbocation. This is the alene carbocation. Then R dash C OH H, then double bond NR plus, but it is unstable. This is unstable, again converted to stable. Here whenever it is unstable, first it is a loss of H plus ion, loss of H plus ion. Then here R dash C OH double bond NR, again which is involving keto-enol tautomerism, 1,3 shifting of proton. So here which is more electronegativity oxygen. Here this bond is moves to here. This is a negative attack to H plus. So here keto-enol tautomerism takes place. Then C double bond O NHR. This is a N-alkyl amide. Generally, the maximum student they are doing that mistake. Only one case here. Listen, I will tell you a small trick. Which one is involving migration or rearrangement? Always opposite of the OH group. So this alkyl group involved in the migration. This alkyl group attack to nitrogen. Then OH here R dash. See, it is converted to double bond. Then NHR. This one. Okay, so here this is these two alkyl group. Whenever they will give the two different alkyl group, that is always go for that opposite of the OH group. Opposite of the OH group, this alkyl shifted to here. For example, they will give the both are same. Go for, in this case, go for anyone which is involving migration, because here these two alkyl groups are same. So that the CH3, then this is a carbon converted to C double bond O, then NHCH3. For example, I'm giving the another question. For example, here C2H5, then C, then CH3, then C double bond, then N double bond NOH. So in this case, which one is involving the migration? Means this is opposite of the OH group. This is ethyl group. So that CH3, then C double bond O, NH, then C2H5. So it is a N-ethyl ethanamide. This is a alkyl group shifting. For example, they will give the cyclic systems. If they will give the cyclic system, this is very, very important. Very important. They will give the ketone. First, it form the hydroxylamine. In the presence of acidic medium, it form that is a ketoxine, NOH. Again, after that, it is a H plus, which is involved whenever it is oxime with H plus, we consider as a Beckmann rearrangement. Here, it is a it form. This is a double bond O NH, then 7-member ring. This is we are calling as a caprolactam. 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 So here 6-member ring converted to 7-member ring. Here 1, 2, 3, 4, 5, 6, 7. So here cyclohexanone converted to caprolactam. This is a Beckmann rearrangement because of here H plus N. How it is involved in the reaction, I will explain the mechanism. So we start with ketoxine. This is a ketoxine NOH first, which is involving proteination. So here these are the lone pairs, always donating electrons towards the carbon H plus ion. So which is involving proteination. So OH, H positive, but it is unstable. So here loss of water. Then we form double bond N plus. Now you have to break this bond any one of the carbon because of here whenever it forms the double bond here these two any one of the carbon involved in the rearrangement, but in this case opposite of the OH group. So if it is open chain, but whereas that the cyclic system go for anyone because these two are the same. So here this bond is moves to the direction this will get the negative attack to positive. So I have to write for your convenience. So N double bond O N, this one is a bond. In between bond, this is a positive charge. So shall I write like this is a here N double bond, this one N, then here this one. So here 7-member ring. Again, one more time I will write here. So here this one and this one. So here I will show that carbons 1 carbon 2 3 4 5 6. Again this one is a positive charge. Okay, so both are same. Again treated with the water. Here where is the source of water? From second step. These are the lone pairs related to the carbocation. So here this is a double bond N. Then this one here OH H positive, but it is unstable, loss of H plus. Then here we get this is a double bond N. Then here 7-member ring. This is a OH again, which is involving ketoenol tautomerism. So here this bond is moved to the direction. This bond is moved to here, negative attack to H plus. So finally, we get that final product here. This is a N double bond O NH. Then here this one 7-member. This is we are calling as a caprolactam. This is a mechanism for the Beckmann rearrangement. Here we discuss about that Beckmann rearrangement. Here always opposite of the OH group, alkyl group involving rearrangement means this alkyl group involving rearrangement. We get an alkylamide. Similarly, if it is cyclic system, here also we get an alkylamide because nitrogen attached to N. This one 1, 2, you have 3 carbons, 4 carbons, 5 carbons, 6 carbon. So it is a 7-member ring. If they will give the 5-member ring, so here if they will give the 5-member ring, it converted to 6-member ring amide. An alkylamide. If it is a 6-member, 7-member ring, this is we are calling as a caprolactam. So it should be caprolactam. It should be 1 carbon increases if it is a cyclic system. So that once check it out all the mechanism. Thank you. Tomorrow, every day I have to put one name of reactions. All of you, please once take it up.